Comenius, Stones, Minerals, Metals, Part 2, Metals. Janua linguarum reserata de metallis periton metallon, orbis sensualium pictus, metalla, metalla. Comenius named this topic metals, but the scope of his topics, stones and metals taken together, is really more broadly what Georgius Agricola in the first systematic treatise on mineralogy called fossilia, things dug up from the earth. For this, see our Praefatio. In fact, both Agricola and Comenius also comprehended as fossilia things dug up from the sea, like coral, as well as unusual substances like amber. Of course, neither Agricola nor Comenius knew of the atomic theory underlying our definition of mineral and metal. Mineralis minerale, by the way, is a late medieval Latin word from which we get the English word mineral. The etymology of mineralis is uncertain. Specifically, Comenius and his contemporaries did not have the knowledge of chemical elements encapsulated in our periodic table, the first version of which is generally attributed to the Russian scientist Dmitry Mendeleev in 1869. To add even more modern perspective, we know that the chemical elements themselves, that is, atoms, comprise less than 5% of the matter in the universe. But to stick with atoms, to add a teensy-weensy bit more of modern perspective, consider that the Greek philosopher Epicurus and his devoted follower, the Roman poet Lucretius, had a quite sophisticated concept of atoms as the indivisible building blocks of the universe. Atomos, atomon means that cannot be cut. But their concept was entirely theoretical. Today, using powerful optical and electron microscopes and systems of lithography, remember that word lithos, we are able to see as well as fabricate material at the nano level. Nanos is Greek for dwarf. 1 nanometer is about the size of 5 to 10 atoms. And then, of course, there are those cool subatomic particles like quarks, leptons, and bosons. Metals comprise about 91 of the 118 elements in the periodic table. Some, like gold, can be found on Earth in their pure or native form, but more often we find them in compounds or in man-made alloys. Metals are variously categorized as ferrous, with reference to their iron content, base or noble, with reference to how quickly they oxidize or corrode, or precious, with reference to their economic value. Notice that the 2-character symbol for most elements in the periodic table comes from their Latin name. The 7 metals known to Greek and Roman antiquity are iron, ferrum, Fe, copper, cuprum, Cu, silver, argentum, Ag, tin, stannum, Sn, gold, aurum, Au, mercury, hydrargyrus, Hg, and lead, plumbum, Pb. Janua de metallis peri ton metallon. Metalla de fodinis eruntur, effodiuntur, equibus, quia liquescunt et russus consistunt, spesantur, varia conflantur. Ta metallea ec ton metallon e orugmaton ex orutatae, ex hon tecomenonta cae palin sun istamenon polaplasia technemata caetae. In this sentence, ta metalla means mines, its most common meaning in classical Greek, and ta metallea, things dug up from those mines, that is, minerals, metals. Later, ta metalla means the minerals and metals themselves, as it does in this Comenian topic de metallis periton metallon. Aurum est perfectissimum, quia purissimum ac ponderosissimum praesertum obrisdum, id est aurum ad obrisdam. Hoc chrysos in telestatos estin, epede ton alon metallon amigesta cae hyperbritestatos esti, malista obrusdos. A obrusta, copied into Latin as obrusa or obrusda, was the use of fire to assay gold. Chrysos obristos is pure gold. Catino immissum, atque clibano vel centies recoctum, ne hilum quidem substantiae essentiae deperdit. Peptes cae tectos in trublioi cae clibanoi hecatontakis, uden tes usias acrantu apobale. Gold, silver, and copper form group 11 of the periodic table, along with Roentgenium, which has only been observed in laboratory conditions. They are relatively inert and can be extracted from the earth in their pure form as native elements. They are resistant to tarnish. Gold and silver, and by some definitions copper, are classified as noble metals, and they also belong to a classification called coinage metals. Argentum huic proxime accedet, quia purum putum est, sed scorias habet quae amburuntur. Exusto autem intertrimento emundatum fit ductile. Ho argyros cataros on, tutu te axiae ingutato scorian ecce, hes peri eccateses elatos ginetae. Silver and metals generally are fusible, malleable, and ductile. Scoria is solid dross or liquid slag. See, for example, in the Bible, Ezekiel, Fili hominis versest mihi domus Israel in scoriam. Omnes isti ais et stanum et ferrum et plumbum in medio fornaces. Scoria argenti facti sunt. And Malachi, et sedebet conflans et emundans argentum, et purgabet filios levi et collabet eos quasi aurum et quasi argentum. Ferrum ut durissimum ferrugine arroditur, e purgatum et induratum aliquoties calubs dicetur. Hosideros sclerotatos men, homos de hypotu iu catestietae, cat aristes de cae sclerotes hoposakis calups legetae. The ancient Greek poet Hesiod, in his Works and Days, Erga kai Hemerae, and the Roman poet Ovid, in his Metamorphoses, each described the fall of man from a golden age through ages of silver, bronze, and iron. Each considered their contemporary era an iron age characterized by violence and injustice. What do you think? Would you say our contemporary era is an iron age? Aeri ad haeret aerugo, ob vividam viriditatem ad tincturas expetita. Toi calcoi ios en iscetae, hu to antos diaten chloroteta, bapais opelimonta cae peripote tonestin. Iron will succumb to iron rust, ferrugo, and disintegrate. By contrast, while copper is also a base metal that oxidizes, copper rust, airugo, which we call patina or verdigris, actually acts as a protective barrier. The Statue of Liberty is a brick structure layered with copper plates, and the plates were soon completely covered in verdigris, but the Army Corps of Engineers at the time concluded the patina actually protected the skin and, quote, softened the outlines of the statue and made it beautiful. What do you think? The words kalkos and ice also designated the copper tin alloy bronze that was actually more widely used in antiquity than pure copper, hence the Bronze Age in archaeology. Stone Age, Bronze Age, Iron Age is a chronological system for dating ancient artifacts. The Roman word for copper was ice. Our word copper comes from late Latin cuprum, from cyprium ice, metal from Cyprus. Orichalcum per vulgata usurpatione est cadmea tinctum ice. Fundi solum potest, non tenuari in lamellas, ob friabilitatem. Ho orichalcos te cadmeae diabrocos utupias alla cutosistin diaten psatirotita. Plato's dialogue Critias tells the myth of the lost island of Atlantis. The island had been wealthy in part because of its abundance of the metal orichalc, mountain copper. Orichalcos is oros plus chalcos. At that time, second in value only to gold, but now, according to the dialogue, a name only. The Romans sometimes wrote this as orichalcum, sometimes incorrectly as aurichalcum, gold copper. By it, the Romans meant a yellow copper ore, or a copper or brass object made from it. By it, Comenius means brass, an alloy of copper and zinc. Cadmea ge was a zinc compound from which our element cadmium gets its name. Kutos kalkos was cast brass, tupias kalkos wrought brass from tupto. Brass is fusible, fundi potest, cutosistin, but not always malleable, non tenuari in lamellas potest, utupiasistin, because with higher contents of zinc, it can be brittle, friabile, psatiros. In modern classification of brass types, white brass with greater than 50% zinc is defined as too brittle for general use. Electro stanum et hoc plumbum mollius et vilius est. Tu electru ho cassiteros, cae tutu ho molybdos malacoteroste cae eutelesteros. In the stones topic, we saw electron meaning amber. Its meaning here is a naturally occurring alloy of gold and silver, which we call electrum or white gold. Chemically, tin and lead are classified as post-transition metals. Physically, post-transition metals are soft, mollis, malakos, and have low mechanical strength. Cassiterite, the main ore of tin, gets its name from the Greek word for tin, ho cassiteros. Galena is the main ore of lead. Tin and lead were sometimes confused and called respectively plumbum candidum, or plumbum album, or plumbum argentarium, white lead, meaning tin, and plumbum nigrum, black lead, meaning lead. Argento vivo hydrargyro nihil mirabilius, liquidum est, nec tamen madet. Tu hydrargyru argyru cutu uden taumasioteron, naru men ontos al uc hygru. Nam sive id super aliquid effundas, sive ei aliquid emergas, sive aspergas, nihil madescit. Udengar en autoi ec caomenoi di ugrinitae. In Western astrology and alchemy, the 7 classical planets and their corresponding deities, see Comenius the Beginnings, are said to rule the 7 metals. The name Mercury retains this relationship. Mercury had a mercurial personality like the chemical element. Helios Kyrieuwe tu Chrysou, Sol regit aurum. Selene Kyrieuwe tu Argyru, Luna regit argentum. Hermes Kyrieuwe tu Hydrargyru, Mercurius regit argentum vivum. Aphrodite Kyrieuwe tu Calcu, Venus regit Ais. Ares Kyrieuwe tu Sideru, Mars regit Ferrum. Zeus Kyrieuwe tu Cassiteru, Jupiter regit Stanum. Kronos Kyrieuwe tu Molybdu, Saturnus regit Plumbum. Comenius, in this metals topic of the Ionoa, has so far covered the 7 classical metals and their major alloys. He closes with what strikes us as a rather random enumeration of additional minerals, or better said, fossilia, and gives them a classification that is utterly foreign to us. The best insight into this final sentence is probably gained by a study of Georgius Agricola's De Natura Fossilium, as we addressed in the Praefatio. To quickly review, Agricola assigned fossilia to 4 types, simple or compounded: terrae, earths, for example clays; succi concreti, usually translated as solidified or congealed juices; lapides, subdivided into common stones, gems, marbles, and rocks; and metalla, metals proper. Lapides, including rocks, gems, and marble, and metalla, metals proper, Comenius has already covered. Agricola's definition of succi concreti were minerals which, when moistened with water, liquefied or softened. Agricola subdivided succi concreti into those that were macer, translated as meager or harsh, and those that were pingue, unctuous. The meager juices were further subdivided into those that congealed from a liquid mixed with an earth, or from a liquid mixed with a metal, or from a liquid mixed with a compound mineral. In this closing sentence of the Ionoa metals topic, Comenius deals with terrae, succi concreti, and compounds composita. In the Praefatio, we also said that the 2 contemporary systems of mineral classification based on chemical composition and chemical structure are the Dana system, the current version is referred to as New Dana, and Nickel-Strunz. For the fossilia in this sentence, we've done our best, where applicable, to indicate both the Agricolan classification and those of New Dana and Nickel-Strunz. If that's more than you want to know, just concentrate on the names and the gorgeous pictures. Like so much else in nature, fossilia can be stunningly beautiful and mysterious. Ochre, rubrica, creta, exempli gratia chemolia, terrae dicuntur. Sal, nitrumque et alumen vitriolumque vel calcantum ac crusocola hi succi macri, sandarica arsenicumque vel auripigmentum et sulfur bitumenque et naphtha hi succi pingues, succi concreti dicuntur. Cinnabaris vel minium, stibi, stimi, stibium vel antimonium, plumbago vel galena composita dicuntur. Cerusa et minium adulterinum facticia sunt. sic quoque crusocolla aurificum gluten. Ochre, miltos hoia he sinopice, chimolia tut esti chimolia geai esin. Hals ta kai nitron, kai stupteria tut esti stupteria ta kai calcanthon, kai eti crusocolla tauta hugra iskna, sandarake ta kai arsenicon, kai theon ta kai asphaltos kai napta, tauta hugra lipara, hugra pectaestin. Cinabari, stibi, estimi, molybdina, sun cacramena estin. Simution kai sandux poeta, hutos crusocolla, crus urgon kai crus ocoon colla. Terrae dicuntur, geai esin, ochre, from the Greek ochre. Ochre is a family of earth pigments. Yellow ochre is a hydrated iron hydroxide we call limonite. Limonite is the main ingredient of ochres. It and hematite are our two principal iron ores. The name limonite was coined in 1813 from Greek lemon, meaning meadow, see Comenius, The Elements, Part 4, Earth, plus ite, probably to describe what we call bog iron ore found in meadows and marshes. By the way, have you noticed that somehow became conventional to name many minerals with the suffix ite? Rubrica, miltos, for example, he sinopique. And this is red ochre. This is an ochre with a sufficient amount of the mineral hematite to make it red. Red ochre was sourced especially from Cappadocia in Asia Minor and shipped via the town of Sinope on the Black Sea, he sinopique miltos. A secondary meaning of rubrica from the Roman Empire is as a chapter heading painted red in a book of law, hence our rubric. The words ochre, miltos, rubrica were variously used to name the earth substance, the pigment produced from it, and the color of the pigment. And here we have a gorgeous picture of yellow and red ochre found together from the Path of Ochres in Roussillon, France. In Agricola, ochre and rubrica are earths, terrae, especially notable as pigments. What we know as limonite is an iron ore which chemically consists of a mixture of hydrated iron oxide hydroxides in varying composition. It is amorphous and not classified as a mineral. Hematite is an anhydrous iron oxide. Creta, chemolia creta, chemolia tut esti chemolia and this is chemolian earth, also known as chemolite, which is a white clay from the Greek island Chemolos in the Cyclades, used frequently in baths and barbershops and in medicine, and akin to our fuller's earth, what the Romans called creta fullonia, and to the phyllosilicate clay mineral we know as kaolinite. Theophrastus mentions chemolian as one of the 4 types of natural earths, getai auto puis, extremely useful for various purposes. Haide auto puis kai hama toi peritoi to cresimon ecusai, he temelias, kai he chemolia, kai he samia, kai, and so forth. Pliny and the Greek medical writers say chemolian earth is a remedy for ulcers and snake bites. Agricola mentions chemolian earth as one of several earths used by fullers to clean wool. Succi concreti dicuntur, hugra pectaestin, sal, hals, nitrum, Greek nitron. And nitrum is sodium carbonate, the alkaline soda ash used in making glass and soap. In its monohydrate form, it is our mineral thermonatrite, and in its decahydrate form, it is our mineral natron. For Agricola, sal and nitrum are closely related succi macri, meager juices made in this case from a liquid in an earth. Sal is our mineral halite, aka rock salt, classified chemically as a halide. Nitrum is what is generally called soda ash or soda, classified chemically as a hydrated carbonate. Alumen, stupteria tut esti stupteria ge, and alumen and stupteria is any of a group of astringent substances such as potash alum and ammonia alum. The word stupteria comes from stupo, meaning ad stringo, to pull or draw together. Alums and vitriol are very astringent. See, for example, our styptic pencil used to draw together a wound from stuptikos. Alum today means either potash alum specifically or a broad class of double sulfide salts. Vitriolum, well, calcanthum from the Greek kalkanthon. And kalkanthon means copper flower, that is, it appears as an efflorescence on copper. It probably means blue vitriol, copper sulfate, though some think it is green vitriol, iron sulfate. As a copper sulfate in its pentahydrate form, it is our mineral chalcanthite. The word vitriolum is a medieval Latin word from vitrum, glass, which you know from stones, suggesting transparency in appearance. The Romans called this substance atramentum sutorium, shoemaker's blacking. For Agricola, alumen and vitriolum or atramentum sutorium are closely related, notably astringent succi macri, in this case made from a liquid and a mineral compound. Chemically, they are hydrated sulfates. Chrysocolla, from the Greek chrysocolla. Chrysocolla in the ancient authors probably most often designated the green copper carbonate mineral malachite, but possibly sometimes the green copper silicate mineral we call chrysocolla today. For several centuries in the early modern period, chrysocolla was also used as a word for borax. Chrysocolla is a succus macer made from a liquid and a metal. It is green in color and again probably referred to the copper carbonate hydroxide mineral we call malachite, a carbonate without H2O, but it may have also meant the copper silicate, which is what chrysocolla means today. Sandarica, from the Greek sandarake, the red-colored arsenic sulfide mineral realgar. Arsenicum, from the Greek arsenikon, and in Latin also called auripigmentum, which is the yellow-colored arsenic sulfide mineral orpiment, which gets its name from auripigmentum. Orpiment is sometimes formed as a byproduct of the decay of realgar, and indeed the ancient authors as well as Agricola observed that arsenikon, orpiment, and sandarake, realgar, were almost always found in the same veins. The etymologists say to arsenikon comes from a Persian word zarnik, where zar means gold, referring to the color of the mineral. It seems likely the Greeks evolved from this an adjective that to them meant masculine, arenikos or arsenikos, from aren, arsene, perhaps because of an association with the powerfully poisonous property of the mineral. By arsenicum, Comenius means the mineral juice, not the pure element arsenic, though Albertus Magnus is said to have first isolated the element many years before Agricola or Comenius, circa 1250. For Agricola, the closely related sandarica and arsenicum or auripigmentum are unctuous juices, succi pingues. Chemically, they are closely related sulfides of arsenic. Sulfur, theon, and this is what we know as the pure non-metal chemical element sulfur, indeed the fifth most abundant element on Earth, and what the Bible knows as brimstone. Herbert Hoover, in his commentary on Agricola's De Re Metallica, see the Praefatio, says the Greek and Roman writers did not have much to say about sulfur, though it is mentioned near the end of Homer's Odyssey. Odysseus and Telemachus have just slaughtered the suitors, hung the disloyal women servants, and gutted and mutilated the goat herd Melanthius. Odysseus then addresses his beloved old nurse Eurycleia. Autar hoge prosa epe pilentropon Euryclean. Oese te eon greu, kakon akos, oese de moi pir. Bring sulfur, old woman, the remedy for evils, and bring me fire. Opera te e oso megaron, so I can fumigate the hall. Of course, the Bible is full of fire and brimstone. For example, that's how God destroyed Sodom and Gomorrah. Kai Kyrios ebrexen episodoma kai Gomorrah teon kai pir. And see what happened to the beast and the false prophet in Revelations. Zdontes ebletesan hoiduo tut estitoterion kai hop pseudopropetes esten limnen tu pyros tes kaiomenes in teoi. Agricola, writing in 1546, praised the medicinal use of sulfur, but lamented the recently invented use of sulfur, quote, in a powder compound which, having been ignited, throws out balls of stone, iron, or copper from a new kind of military machine. Now, what do you think he means by that? Bitumen, asphaltos. And here we see a sample of asphalt from the Dead Sea, which was called e asphaltitis limne. In Agricola, sulfur and bitumen are a second closely related pair of succipingues. Sulfur we now know to be a chemical element, bitumen a fossil fuel. Naphtha, from the Greek naphtha. Naphtha is an ancient Persian word that worked its way into Greek, Latin, Arabic, Syriac, and Hebrew. Agricola's primary examples of succipingues were the pairs Sandaraca, Realgar, and auripigmentum, orpiment, and the still more unctuous sulfur and bitumen. Under bitumen, he subsumes, among other substances, naphtha, malta, and pisaspaltus, from the Greek pisaspaltos. He says the liquid form of these is now called petroleum, which means rock oil, apparently the first appearance of this word. And as a black liquid, he says it is sometimes also called pix because of its resemblance to pitch. Herbert Hoover says the Greeks and Romans distinguished between asphaltos, bitumen, as the hard material, pis asphaltos, malta, as the viscous, pitchy variety, and naphtha as petroleum proper, though the latter was also frequently referred to as liquidum bitumen. Composita dicuntur, sumcacra mena esin, cinnabaris, from the Greek cinnabari, also called in the Roman authors minium. We've already seen cinnabar as the ore that produces the metal mercury and the pigment vermilion. Greek cinnabari, etymology uncertain, Latin minium, from the river Minius in Spain, where cinnabar was mined, and later vermilion, from Old French vermillon, a word that ultimately goes back to Latin vermes, insect, namely the Kermes vermilio, that produces a similar red dye, were used variously to represent 1. The mercury sulfide ore from which mercury is produced, what we call today cinnabar. 2. A type of cinnabar adulterated with a lead oxide. 3. That lead oxide itself, recognized today as a distinct mineral, lead tetroxide, red lead, what we call today minium. 4. The red pigment produced from powdered cinnabar, and 5, the color itself, which we call vermilion. In proper Roman usage, according to Pliny, Cinnabaris indica was dragon's blood, probably a tree rosin, used as an ingredient in medications, while Cinnabaris nativa was another name for minium, red lead, Greek cinnabari. Physicians, according to Pliny, were stupid enough to mix up the two cinnabares and give their patients the highly toxic red lead instead of the dragon's blood. For Agricola, cinnabar was a compound, a compositum of an earth and a metal. In mineralogy today, we clearly distinguish between the metal sulfide cinnabar and the red lead metal oxide minium that sometimes coats cinnabar. Stibi, stimi, stibium, from Greek stibi, estimi, and in medieval Latin and beyond, antimonium. And this is the sulfide mineral stibnite, the naturally occurring form of the gray metalloid antimony, which gets its symbolic name Sb in the periodic table. Stibnite was used since early ancient Egypt as a medication and a cosmetic, for example, as an eyeliner. Pliny calls it the lapis spumae candidae nitentisque non tamen tralucentis, the stone of shining white foam. And he also distinguishes a male and a female variety, duo eius genera, mas ac femina. The latter, the femina kind, is the more approved of, he says, the male stimi being more uneven, rougher to the touch, less ponderous, not so radiant, and more gritty. The female kind, on the other hand, is bright and friable and separates in laminae and not in globules. Stibi for Agricola was a compositum of a stone and a metal. Stibnite is another metal sulfide. Plumbago, well, Galena Molybdenum. We already know the word for the metal lead, plumbum, molybdos. Here Comenius gives us the word for lead ore. Plumbago, molybdena, can designate the lead ore galena or one of the byproducts of lead ore smelting, such as the two Agricola calls plumbago and spuma argenti, foam of silver, Greek lithargyros, silverstone, from which we get the modern name litharge lead oxide. Galena ore often contains a percentage of silver and is in fact our primary source of silver, as it was at the silver mines of Laurium in Attica. Plumbago, lead ore, Pliny called it galena, as do we, is another compositum of a stone and a metal, according to Agricola. We've seen cinnabar, a mercury metal sulfide, and stibnite an antimony metal sulfide. Galena is a lead metal sulfide. Cerussa et minium adulterinum facticia sunt, psimution cae sandux poeta. Psimution, cerussa, was white lead, the basic lead carbonate made from white lead ore, cerussite, but also naturally occurring as the mineral hydrocerussite. Women since antiquity, including Elizabeth I, painted their face with it until the modern discovery of lead poisoning. Elizabeth psimutioi to prosopon, probably from the product Venetian cerus. Sandux, minium adulterinum, was a red lead. In mineralogical Latin, metals are nativum, pure, or adulterinum, impure, or facticium, made, in Agricola's terminology, made by processes inside or outside the furnace. The process of making white lead by dissolving lead ore in vinegar was described as early as Theophrastus. And according to Dioscorides, the red-colored sandux was made by heating white-colored psimution and was considered an artificial minium or red lead. Agricola says sandux was made by burning lead. Today, sandux is an obsolete term. Sic quoque crusocola aurificum gluten, hutos crusocola, crus urgon takai crusocoon cola. So now let's review the entire sentence. Ochre, rubrica, creta, exempli gratia chemolia, terrae dicuntur. Sal netrumque, et alumen vitreolumque vel calcantum, ac crusocola, hi suci macri, sandarica arsenicumque vel auripigmentum, et sulfur bitumenque et naphtha, hi suci pingues, suci concreti dicuntur. Cinnabaris vel minium, stibi, stimi, stibium vel antimonium, plumbago vel galena composita dicuntur. Cerusa et minium adulterinum facticia sunt. Sic quoque crusocola aurificum gluten. Ochre, miltos, hoia he sinopice, chemolia tut esti chemolia geae esin. Halsta cae nitron, cae stupteria tut esti stupteria tec cae calcanthon, cae eti crusocola, tauta hygra ischna, sandarace tec cae arsenicon, cae theon tec cae asphaltos cae naphtha, tauta hygra lipara, hygra pecta estin. Cinnabari, stibi, stimi, molybdina, sum cacramena estin. Simution cae sandux poeta. Hutos crusocola, crus urgon tacae crusocoon cola. Orbis pictus, metalla, metalla. Plumbum molle est et grave. Ferrum durum est. Durior vero calubs. Homolybdos malacosisti cae barus. Hosideros sclerosisti. Scleroteros de hocalubs. Artifices faciunt hoi technitae poiusin, ex stano cantaros, ec tu cassiteru tus cantarus. Ex aere aenea, ec tu calcu calcea. Ex ore calco candelabra, ec tu ore calcu talucnia. Ex argento unciales argentaos, ec tu argiru argiria. Ex auro ducatos aureos, ec tu crusus statedes. Argentum vivum semper liquet et consumit, devorat, derodet metalla. To hydrargiron argyros tutos, pantota naronesti, ca anabrosque cat estie ta metalla.